But what about negative 3 and positive 3 themselves? Can I use 3 and negative 3? Sure, because if you use either one of them and plug it in there, it'll be 9 minus 9, which is 0, and we can square root 0. So here's what we're saying. For the domain for this problem, it'll be everything before negative 3, so that's negative infinity all the way up to negative 3, which is included. We're going to skip the bad stuff because all the numbers in here would lead to the square rooting of a negative, which is bad. And then we resume from positive 3 into the right forever and ever and ever. Okay, now how about this one here? So let's see what this says. Take the stuff inside of the square root, set it equal to 0, solve, and you'll see that we get plus or minus 4. So let's go to positive 4 and negative 4, and let's use some test numbers. I'm going to test 0, 5, and negative 5. And I'm looking just at the numerator for now. Can I use positive 5? No, because that would be 16 minus 25, and that's negative. So this is a no. Can I use negative 5? No, for the same reason. If I use negative 5 or anything that lives in this region, it'll be the negative being square rooted. That's bad. Can I use 0? Yes, because that'd be 16 minus 0, which is 16, and we can square root a positive 16, so this is yes. What about the 4s themselves? Can I use 4 there, negative 4 there? Sure, because you'd be square rooting 0. So that's a yes, and that's a yes. However, look at this denominator. This is telling you that x cannot equal negative 1, because again, we have to be mindful of two things. Not square rooting negatives, but also not dividing by 0. So this is going to be an interesting one. Let's go to a number line, and let's make a cut at negative 4 and 4 as we said. We already did that there, but let me do this again. So we said that this is no, that this is yes, and that this is no, and then we said that the 4s were yeses. However, a number that we have to get rid of is negative 1. And negative 1 is going to be like right here. So really, it's going to be like this. Watch. It's going to be including the negative 4 up to the negative 1. And then let's go from negative 1 to positive 4. You see that? So we're going to include the 4s and everything between them except for negative 1. So let's see. So this answer, that domain would be like this. From negative 4 to negative 1, union from negative 1 to 4. You see what that's saying? That's including all the stuff between the 4s except for the negative 1. Okay, we're almost there. Let's try one more. These ones here. So let's see. In the numerator, I'm going to set it equal to 0 and solve, and I get 13. So that's with the square root. So this means that I'm going to make a cut at 13, and I'm going to test like 12 and 14 in the numerator. Can I use 12? Sure, because that'd be 13 minus 12, which is 1, and I can square root that. Can I use bigger than 13, like 14, 15, 16? No, because that would be square rooting numbers that were negative. So this is saying that I should use everything that's before 13. However, there are some numbers that we cannot use. That's telling you that you cannot use 9, and this is telling you that you cannot use negative 7. So let's take a look. So what we're saying is we have to use 13 or smaller, but we have to remove these numbers along the way. So the 9 has to be removed and the negative 7 has to be removed. So we're going to go like this. We're going to go like that. So let's go all the way up to 13, but let's kick these numbers out of the party. So the domain would be from negative infinity up to negative 7, because we're going from left to right. We remove this one. We include the stuff between them. Okay. And then we jump over the 9 and we go all the way up to 13. Where, of course, the 13 is included. Okay, one last one here. So there's no division because there's nothing in the bottom. So let's just be mindful about not square rooting numbers that are negative. So let's take a look. This can actually be factorized inside. Right, I can take out an x from within. And now this here, what are the numbers that make these 0? So 0 and positive 7. So these are the numbers that make the inside 0. So this is where I make my cuts on the number line. Whatever numbers make the stuff inside the square root 0, that's where you make your cuts. And now let's pick some test numbers. Let me test these numbers here because these numbers live in these respective intervals. Test them into the original problem. If I plug in -1, in here, what am I going to get? If I plug in -1, that's going to be 1 plus 7, which is 8. And that's okay because it's a positive. So this is good. Can I use +1 in there? If you plug in 1, it'll be 1 minus 7, which is the square root of -6. And that's all kinds of bad, so that's a no. If I use 8, it'll be 64 minus 56, which is the square root of 8, so that's okay. So this is good. What about 0 and 7? If I plug in 0 or 7 into there, I'd be square rooting 0, and that's okay. So it seems like this would be the domain. It seems like it's everything up to here and everything from there except this piece in the middle, because that's no, no, no. So it'd be negative infinity up to 0, and the 0 is okay. We skip this, and we continue from 7 all the way up to infinity. So this is how you can look at the domain algebraically by remembering these two things. Don't divide by 0, and don't square root negative numbers.